Awesome. Thanks, Rob. Can folks see my can you see me on the webcam? We've not done a guest lecture with a webcam yet. So awesome. Fantastic. Well, yeah, thanks for the intro, Rob, and thanks for having me. This is pretty fun. It's been a long time since I've done anything Xamarin University, so it's cool to go from dean to being a guest lecturer. That's a lot of fun. So I am now CEO of Wilderness Labs, and I'm a co-founder there, and there's a couple of others of us in there, and we're having a lot of fun. Wilderness Labs, we created to make building connected things a lot easier. And right now, hardware's pretty hard, and if you want to do smart connected hardware, there's sort of a lot of different options out there, but a lot of it's really low level, and you really have to put on your hardware hat, and it's not super easy today. And so what we're trying to do is make hardware development as fast and easy as software development, and bring our favorite language, C#, again, to hardware. So kind of a little bit like what we did with Xamarin, but for hardware. And today, I'm going to walk you guys through creating a very simple connected appliance. And what we're building is kind of what I would say is a smart, or a dumb smart outlet. So what I'm going to walk you through is I've hacked a coffee maker so that I can, from my phone, I can control it. Hopefully you guys can see it. I have this app that's running on my phone, and when I hit the big start button, my coffee maker, I have to click it on my phone, not on the QuickTime. When I hit the start button, my coffee maker turns on, and this is all powered by Wi-Fi. I'm connecting to it, I'm connecting to it over Wi-Fi, and it's a self-contained unit. It's actually plugged into the wall. There's no USB into a computer or anything. And like I said, when I turn it on, the coffee maker comes on, and when I turn it off, the coffee maker turns off. So pretty fun. It's a simple hack. It's something that anyone can do at home with with a Netduino Wi-Fi, or if you want to run it over Ethernet, a Netduino 2 Plus or a Netduino 3 Ethernet, and then just a few dollars worth of components. I think on this board here, on what we're calling the appliance control board, I think the whole thing might cost $15. We're going to walk through this, but it's got a relay which controls actually the power, and we'll talk about what that is. Like I said, I've got a Netduino 3 Wi-Fi on there. I've got a breadboard for additional prototyping and sort of expanding, doing more sophisticated projects. And then I'm powering the Netduino with one of these cheapo USB power chargers that I got them. They're like $2 at Amazon. I got a bunch of them, and I literally wired it in to an extension cord. The extension cord is plugged into these two power bus bars here. I've got neutral and I've got hot, and then the USB adapter is plugged right into there, and then the coffee maker is actually plugged into the neutral, and then this relay, and we'll talk about what that circuit is in just a bit. So one of the things is about connected hardware and this sort of space is that there's a whole class of products out there that have yet to be built. Everyone knows about Ring and Nest, and there's some few other things out there, but for the most part, the space is largely untouched, if you will. The opportunity hasn't really been taken advantage of in any major way yet. And connected hardware, smart hardware, is a big part of the next major step of the computing revolution. There's kind of a few different axes that we're evolving along right now in computing, and one of them is AR and VR, and that's one axis that things are really accelerating along, and another big one is hardware. And folks say IoT, but IoT is such a funny word because it's a stand-in. It's a stand-in for the panoply of things that is connected hardware, and really the thing that's driving that is this need for ubiquitous computing experiences or connected experiences. The idea that wherever you go, there's contextual awareness about your presence and your desires, and machines and things around you are doing things for you and making your life more rich. And you come home, the idea of coming home to a smart house, you come home, you drive up, and your garage door opens and your coffee starts brewing, and maybe your rice maker goes, and the appropriate lights come on, and maybe your favorite radio station comes on, etc. All of these things, that's just like one example, but the things that people will do with connected hardware has really yet to be tapped. I mean, that sort of connected home experience is just one idea of what people think will happen. But with any new revolution or platform, you never really know what people are going to do, and they're going to surprise you with what they're going to build. And that's something that we learned at Xamarin, is that, man, the mobile apps and the things that people that built with that were really, really surprising and creative. And hardware will be the same way. And the miniaturization of hardware is really driving this revolution. Because now we have these microcontrollers that are very low energy. You can run a Netduino on a solar panel. You could indefinitely. You can run it off of a battery for a very, very long time if you're smart about how you code. And yet they're very, very powerful. They can do a lot of really interesting things. And so the technology, the hardware, the innovations there are will power the solutions of tomorrow. But as I said today, it's a little rough early. It reminds me of the early days of Xamarin, in which the mobile landscape was still the Wild West. It was still, the sky was the limit, and there was all kinds of opportunity there, but it was also still kind of a rough experience. So we're trying to make that easier. And so Wilderness Labs is we're building a vNext hardware platform, and it's a spiritual successor built on Netduino, which we now own. We acquired Netduino, and we're also giving Netduino. We're sort of building on Netduino and making Netduino a lot easier to develop with, and making it so that you don't have to put your hardware hat on to actually build hardware. And today in this guest lecture, I'm going to show you something that I'm actually really excited about, and we haven't released it yet. So you guys are getting a preview of this. We're going to release something called Netduino Foundation on Thursday, and I'm going to show you, give you a sneak peek of that as well. I have the Xamarin University mug. Look at that, spring fling. So yeah, today what I'm going to talk about is a very specific solution. We're going to, like I showed you, the connecting of the coffee maker, and it's got three parts to it. It's got the appliance control, which breaks down into two parts actually. We're switching household mains electricity. So in America, that's 110 volts or 120 volts, and in Europe, that's 220 or 240. And then we're exposing that control over a web server, and then we're connecting to that web server. Those endpoints that are exposing the control to the relay via Xamarin app. So we're going to walk through that. So just out of curiosity, since we got so many people on the line, I'm curious. how many folks here are familiar with, have heard of Netduino or are familiar with the .NET micro framework?
And you should see this on your screen right now if you want to just go ahead and answer.
I see it on the wrong screen over here. I don't know how to get my computer.
Well, we assume that you've heard of Netduino before, Brian. All right, so I'll give it just a few more seconds. It looks like most people have. We're at about 69%,
All right.
31%.
All right, look at that. 2/3 of you have heard about Netduino or used Netduino or .NET Micro Framework. That's fantastic. That's great. So for the 30% of you that haven't used Netduino, let me tell you what a Netduino is and what a programmable microcontroller is, really. So Netduino is it's a hardware development board, and at the heart, there's a Netduino right here. I hope everyone can see that. So this is a Netduino 2 Plus. This is one of our older models, and then here's a Netduino 3 Ethernet. So it's Netduino 3 with Ethernet connection, and then the Wi-Fi one is back here. And Netduino is a board in the same form factor as Arduino. I assume nearly everyone has heard of Arduino. It's in the same form factor as Arduino. So Arduino shields the things that sit down on top and add extra peripherals and stuff fit actually Netduino boards. And at the heart of Netduino is this chip. It's a Cortex M4 programmable microcontroller. And a programmable microcontroller is it's like a CPU, but it's a very specialized CPU. Unlike a CPU in like your computer, for instance, it's incredibly power efficient. It's very low energy usage. And in fact, you can put it to sleep and you can run it on a battery and wake it up, and you can run for years. And it also has a lot of specialized, what we call GPIO, or general purpose input and output. And so on the Netduino board itself, we have these headers. And and I'll pull up a picture here of, you can see it on the presentation as well. So the headers here expose input and output possibilities to control external hardware peripherals. And on the Netduino, we have a set of digital I/O, which is this whole set of headers here, and those do traditional digital 0 and 1 high-low voltage signaling, which allow you to communicate to things digitally. And so there's a bunch of protocols for peripherals such as UART or COM. You know, I'm sure a lot of folks have heard of, have used a COM port before. That's a serial protocol. And then there's a sort of more specialized serial protocol called SPI. And then there's I2C, and there's CAN. There's all kinds of these different hardware protocols which allow you to talk to different hardware peripherals. Now, Netduino exposes the ability to program these and communicate with peripherals over these different digital pins. Now, there's some really interesting protocols here. For example, I2C is something that Netduino supports, and I2C is a chainable peripheral protocol. And what that means is, so for example, on this one here, on this setup, I've got a prototyping breadboard, and I've got these two sensors, and both of these sensors are I2C sensors. One of them does temperature and humidity, and one of them does barometric pressure and temperature. And they're actually both connected to the Netduino via just two lines, and they share the same communication bus. And so with I2C, you can actually add virtually an unlimited number of peripherals on the same bus, and each one of them is addressed via or you can speak to it via a different address. So when you create a new I2C peripheral, you simply specify the address, and then you're up and running, and you can talk to it. Other protocols that are interesting are serial. So there's a number of different serial and serial derivatives or varieties. SPI is a common one, and UART is also another. RS-232 serial over UART is the common one, and that allows you to speak to like computers and just generally talk to different things. You can talk to other Netduinos, you can talk to Raspberry Pis, you can talk to Arduinos, you can talk to all kinds of stuff. So that's what we have on the digital I/O. And by the way, on digital I/O, we can also because we can turn things, we have control over that, we can turn things on and off. And in fact, that's how we run our relay in this coffee pot. And we're going to look at that code and actually see how that works in just a bit. The other interesting thing that's on here is analog I/O. And this is something that you'll find on programmable microcontrollers, but you won't find on things like Raspberry Pi, which is really more of like just a little mini Linux computer. And analog input and output is actually super interesting. So that's where the sort of the rubber meets the road in terms of real hardware development. And the reason why is that many sensors that are out there are actually analog sensors. And what that means is that instead of communicating digitally, the sensor actually returns a varying voltage depending on whatever it's sensing. So for example, let's say we have a temperature sensor, and it's good for between 0 and 100 degrees Celsius. That means that at 0 degrees Celsius, it would return like 0 or close to 0 voltage. And at 100 degrees Celsius, it might return 3.3 volts, and at 50 degrees Celsius, it would return 1.65 volts, half of 3.3. And on this microcontroller chip itself, it has this really fancy thing called an analog to digital converter. And the analog to digital converters are really, it's a really brilliant piece of hardware, and what it does is it reads that analog signal and then it converts it to a digital value. So you can access this in code to read that analog signal. And one of the things, or the thing that's so special about Netduino specifically, is that Netduino runs the .NET micro framework, which allows you to program and develop hardware using net. Now the .NET micro framework, can everyone still hear me? I'm getting a notice that my internets are unstable.
It kind of freaked out for just a second, but I think you're back to being okay.
Cool. We are wilderness labs after all. I'm out in the wilderness. So the .NET micro framework is a subset of the .NET framework, and so there's some things that it doesn't have. For example, it doesn't have generics, which is a bummer, but it does have a lot of the other parts of .NET. But it allows you to program real hardware using C#, and there's debugging, real-time debugging and stuff, and it's really a fantastic experience. It's a lot of fun. And so that's kind of Netduino and programmable microcontrollers in a nutshell. Now we started Wilderness Labs around about a year ago, and we've been hard at work sort of expanding on Netduino and making Netduino and hardware development a lot easier. And along that way, we've done a lot of interesting things. So we've made Netduino full cross-platform now. So we have Mac support. You can use Visual Studio for Windows, or you can use Visual Studio for Mac. I will say that today the Visual Studio Windows experience is much better because Rosalind broke our debugger on Visual Studio for Mac, which I think we're very close to a fix for. But just know that if you are actually doing this development, I recommend Visual Studio for Windows, which is probably not a huge issue because most people, that's what they're using today. but it does support Mac, and we wrote some new tools to allow you to configure your network and configure the card and stuff or the Netduino on Mac. And we rebuilt the supply chain, and so now you can actually go and go to Amazon, go to Mouser.com if you're international, and you can buy an Netduino. So I hope I hope everyone here will go and and keep our lights on, and pick up a Netduino and go start building. I guess one of the things I missed here is that when we acquired Netduino. So Netduino was sort of heading for the dustbin of tech history. It was created by a company called Secret Labs, and Secret Labs had kind of they had a failed Kickstarter, and they were having kind of a meltdown. And when Netduino came out, I had been working with some various hardware platforms for a while, then Arduino and Parallax Stamp before that and whatnot. And I really fell in love with Netduino because I love C# and being able to program hardware in C# was really a fantastic step forward. And so when I heard that Netduino was struggling, we picked it up, and we gave it a new life. One of the things that Netduino never really had was it was never a real development platform. Docs were sort of missing, and their driver support was hard to find, and the community was spotty and stuff. And so since we have started Wilderness Labs, we've done quite a bit around Netduino, and one of the things that I'd like to point folks to is our fantastic documentation and developer community. You can go to our developer site at developer.wildernesslabs.co, and there's fantastic documentation there. There's a great electronics tutorial there. So if you're new to electronics and you want to learn from the ground up, there's some really good content. Really good content there. We start from atoms, and we go up from there. You learn Ohm's law and Kirchhoff and DC circuit analysis, etc. And then there's just a ton of other good documentation on there. If I recommend checking it out. Here's a page that shows the pinout of the Netduino and all the different. I talked earlier about the different protocols that are supported and the different things that the Netduino can do. Here's a pinout diagram of all of those, all of the places that those protocols are exposed, and where PWM, which we're going to talk about it in a bit, are available. Hardware PWM and our I2C and our COM ports, etc. So definitely check that out. And then also community.wildernesslabs.co is also a fantastic place. If you want to build hardware and you are looking to get started and you run into challenges, or you want to talk to other people about projects, etc., it's a great place to take a look at. There are folks on there doing a MIDI project together. They're controlling electronic instruments via Netduino, and Netduino is very it's very low energy, but it's very powerful, and so you can do MIDI work with virtually no latency. And so check that out, and say hi to folks there, and like I said, get help, etc. So with that said, with kind of recapping what you guys now should all understand, I think have a good understanding of what a microcontroller is, and what what Netduino is, and the micro framework. I'm curious also how many folks here have actually developed with Netduino. So about a third of you, or so 2/3 of you know what Netduino is, know what the micro framework is. But how many folks have actually done any development? Looks like responses are coming in. Survey says, wow, this is great. So a little under 20% of you have actually done, so 1 in 5 have actually done Netduino development. So that's fantastic. So for 80% of you, the actual details here, the nitty-gritty, will be new. So that's cool. Thanks for your participation there. Thanks for the information. So let's walk through building this connected coffee maker solution. So I mentioned the first part of this is power control. And the way that this works is that the Netduino itself is controlling a relay, and then the relay is controlling the coffee maker. And if you can see my, I can show you here, if you can see my webcam. So this is what we're calling our appliance control board. And by the way, this is up on our, you can 3D print that plastic backboard here, this baseboard, and the designs are up on our 3D print designs repo, and you can pull them down and then print this out. There's some other baseboard options there as well if you don't need the extra space for a relay and all this. You can also find instructions for all of this up on our blog. So if you go to blog.wildernesslabs.co, it'll have instructions for all of the assembly, as well as all the product sourcing for all the components. Because on here we have some interesting things. We have these power buses, and then the relay board itself. And I think the relay board is about $7 or $8. This, you know, a breadboard is a couple bucks, and then there's our fancy DC AC to DC converter here, our USB charger. The whole thing is, I think, like 12 bucks minus the microcontroller. And the way that I've got this wired up is that this is plugged into the wall. This is just an extension cord that I've cut and I've snipped, and then I've split the two leads and I put it into these power buses. And here I've got, you can see I've labeled it. There's neutral and hot, although it doesn't really matter with alternating current. Polarity is not really interesting because the electrons are flowing back and forth rather than one wire is flowing one way and the other wire the electrons are flowing the other way. So all that matters is that to power this coffee maker, all that really matters is that the two leads from the coffee maker extension or the plug-in cord are connected to the two leads of the extension cord that's coming from the wall outlet. And now, in this case, what we have is that wall outlet comes in, and then one of them is directly connected, one of the leads from the coffee maker is connected directly to the neutral, and then the wall outlet power comes in, the hot comes in here, and then I have a lead coming off the relay, and then actuates. It closes a connection to the other side of the coffee maker power. And so what that does is it completes a circuit so that the electricity can flow between the two wires. And we control that relay. The relays, by the way, are really, really interesting. So relays conceptually are an electrically controlled switch. So conceptually they are, or physically they are electrically controlled switch. So conceptually, they're very similar to like a transistor in that you give a transistor power and then you can control a little bit of power and then you can control a lot more power. But relays take it one step further by actually electrically isolating the two circuits. So the circuit that is the control circuit and the circuit that is the power circuit are actually electrically isolated. And the way that that works is that most relays are electromechanical. And so they're actually a little magnet-driven switch. There's a little tiny solenoid in there. And when you power that switch, then it switches the magnet, or it gives power to the magnet, energizes that magnet, and then that magnet controls the actual physical switching. So this is really fantastic because with a very small amount of current, the current that's available from the Netduino, in this case 3.3 volts, we're actually switching 110 volts AC current. So not only can you switch a much higher amount of current, but you can even switch a completely different type of current because they are isolated. And when you turn this on, if you can probably hear that, So as I hit the button on my app, and let's see, pull up the app. So as I hit this button on the app, you can actually hear and see this. You can hear that magnetic switch switching. And in this case, there's also an indicator on this little relay board of when that relay is on. So relays are used everywhere. Relays, for instance, are used in your car for to control your headlights and various other things. Relays are really used all over the place. And so the way that we control this relay, as I mentioned, the digital I/O earlier, the digital I/O header. So we've hooked up this relay to. This is a 2-channel relay, by the way, so you can actually control more than one circuit. In this case, I'm only using one. It's just to turn this coffee maker on off. So I only need one of these. But I've hooked the relay into. First of all, the relay gets power and ground so that it can actually actuate that switch. But then the actual relay itself is controlled by a digital pin. And so to turn on the relay or to actuate it, we create a new output port, and an output port is on the C# here is right here. An output port is a digital pin that we can write to. And so we create a digital pin. In this case we're using pin digital 2, and then when we want to turn on the relay, we call this relay.write, or this pin, this output port.write, and we pass a true. And true corresponds to 1 or high. So a digital I/O can either be at 0 volts or ground common, or it can be high, so 3.3 volts. So all we have to do here is we create a new output port, and then we set it to high, and that actuates the relay. So that's really interesting because with very low power, we can programmatically control household mains electricity. So you can imagine you could with a couple of relays, you could make all kinds of interesting appliances. You could hack all kinds of interesting appliances at your house and control them in interesting ways. The next part of this, however, is so that's interesting. As long as your Netduino is connected to your computer, you could sit there and you could write to that pin, programmatically, or you could wire this up to the onboard pin, or sorry, the onboard button on Netduino. There's a button on Netduino that is built in, and you could wire up this that digital I/O to listen to events from that button, so that you could hit the button, and then that could turn on the coffee maker as well. But in this case, we've done something even cooler. We've sort of taken it to the next step, and we've exposed that control via a web server. And so we have this this web endpoint, web API endpoint, and we can actually talk to it via GET and POST requests. And so here's Postman. This is showing. So Postman is a little utility for testing RESTful endpoints. And you can see I have this. This is the IP that my app, my .NET Micro Framework app is running on, and this is one of the calls. Is the status, and I can hit the send button here, and then I get this JSON back. Is power on, false, because I'm just getting status. And the way that we've done that is that we've built this server. It's a purpose-built server for Netduino. It's called Maple Server, and you can install it via NuGet package. And by the way, I think I forgot to mention this earlier, but Micro Framework applications are just like other .NET applications that you're used to. So here's a .NET. This is actually our .NET Micro Framework application of our application host and our remote. But once you've installed the .NET Micro Framework, you can go in and create a .NET Micro Framework application just as you would any other application. You can see in Visual Studio for Mac, it's here in other miscellaneous, and then a micro framework console application or a library that can be used in in your application. And the way this works is that Netduino runs a little micro OS called TinyCLR, and it's a single app model. So you build an application and you deploy that application, and that application is the one application that runs. And so in our application, in our Netduino, our connected coffee maker, we've got this what we call this appliance host, and it's running Maple Server. Now, Maple Server is an ultra lightweight, modern RESTful web server built for Netduino that has built-in JSON support, and it's very, very easy. We've made it super simple to use. And so here is the code actually to define those endpoints. So our endpoints, our RESTful endpoints are, we've got a get endpoint of status, we've got this and two post endpoints of turn on and turn off. And the way that we handle this is that you add Maple Server to your project, and then you inherit from request handler base. And then what you do is that you prefix your methods with get or post, and we use reflection to walk through your custom request handler, and we turn these methods into web endpoints. And so the endpoint for this get status actually becomes status, and turn on and turn off become these post turn on, post turn off become turn on and turn off. And we automatically parse query string and get requests and post the form fields. And so there's a hash table that we expose called query string or form, and you can access the posted data that way. And we also automatically deserialize we automatically serialize output. So this is the entirety of the code to expose our control for our coffee maker. So as I said, we've got get status and post turn on, post turn off. Get status returns this calls status response, which just returns a status response. We'll take a look at that in a sec. And then turn on and turn off call toggle power and pass true or false. And what we're doing here is that we have this static ports class, which in the ports class, you can see here, all we're doing is creating new output port and just making them statically available to our application. So no hidden functionality there, nothing super interesting. But we're controlling the onboard LED and the onboard, in this case, the digital pin 1. I know the last one said digital pin 2, but what we're doing here is that when we turn on the power, we're not only writing to that pin, but we're also writing to the onboard LED so that folks can see visually kind of like a debug output, if you will, whether or not we're turning that relay on. So you could do that even if you don't have the relay hooked up. In fact, before we had the relay hooked up, we were just turning the LED on and off. So that's what we're doing there. That's all that is. And then status response is pretty simple. We are creating a new, we're specifying some information in our response, in our context, and then we're creating a new hash table, and then Maple Server automatically serializes our is power on, and then we can send it back out. There was a question in here as well about if you could authenticate. So in this case, there's no authentication here, but you could use Maple Server and pretty easily write your own authentication. It has access to the HTTP request, so you could build in some sophisticated authentication where you just do standard username, password. You could probably do some certificate stuff if you wanted SSL supported. So you could actually secure this if you want. And let me show you. This is this is the app. This is the application host app that actually runs on the Netduino. We saw the ports, and then here's our request handler. Now this is just the same thing that we saw over here. It's just a little more, just not as compressed. So you've seen all of that code. And the other interesting part of this is our program .cs. And so this is our static void main, and this creates our application classes, a singleton application instance, and then basically says, keep our app running forever. So this is while app is running, and because this is a single application model, you have to keep your main loop alive. So you could do thread.sleep timeout.infinite, or in this case, if we wanted to have a pattern in which the app shut down for some reason, we can actually just check to see if it's actually running. And so the other code in here that is I would say somewhat interesting is we have to initialize our network. So you think of Netduino as a standalone computer, and so when you turn it on, when you plug it in, it has to go through and it has to request like a DHCP, or it has to configure its static IP address. It has to wait for a DHCP response from its router, and it has to initialize its network interface, etc. So there's a bunch of code in here to actually initialize the network, and there's a bunch of debug stuff, so you can see actually when it runs, it outputs all this to the console, and then it makes a little GET request just to test the URL to make sure that we have connectivity. But all this code is actually up in our repo. If you were to go to GitHub Wilderness Labs, Netduino samples, and then under Connected Coffee Maker, you can find the appliance host and appliance remote. And there's a bunch of code in here to do this network stuff, but I want to say this isn't terribly interesting because we are actually added this to a library, which we're going to talk about in a bit. That some secret stuff that we haven't announced yet. But we've added that to a library, so you can actually just make a call on your own app just to a single line, and then it handles all of that stuff for you. We've hidden a lot of that complexity. So that's the micro framework app, and as you can see, it's if you've done C# development, you've done Xamarin development, if you've done any kind of .NET development before, it's all very familiar to you. We're using the same classes. We're using HTTP request and whatnot. But the .NET micro framework adds a few things. It adds an API for all of the I/O, all the input and output. So digital access, and then also, and I didn't show any of this, but there's also, as I said, the analog to digital converter. So we have access to that, etc. So that's the .NET micro framework side of the house, and I'm sure you guys will have tons of questions that we'll run through on that. I want to jump over to the Xamarin app. So as I mentioned before, and as I showed you with Postman, the Xamarin mobile app is very, very simple. We're basically using HTTP client. We're creating a new request, and a new request, and we're posting it async. And in this case, where the application has two screens, it has this control screen, and then also has this configure screen in which you can put an IP address. Now, one of the things actually that we're doing here is today you have to add this IP address manually, but we're actually adding UDP broadcast to Maple Server, so that we could actually just enumerate a list of broadcast appliances that are running this, and you can just select it. So that's something that's actually coming down the pipeline. But in any case, the app has just 2 screens, and it's built in XAML. I'll show you the app here. There's the configure page, which that's where you put the IP address in, and then there's the status page. It's very simple. There's only 3 items on the page. There's a couple of headers. There's the header. There's a couple of labels. There's the header label. There's a status label, and then there's an action button, and that corresponds to this. Here's our header. This is our status, whether it's on or off, and then our button. And if you haven't configured your appliance, then this says configure instead of start. And of course, as you start it and it gets the status, then it changes to stop as well. So very, very simple. You guys are all, you folks are all Xamarin developers, and so you could make this way cooler. You could do lots of interesting things there. And then the code to actually run this is in this API helper, and it's pretty simple. We have our, this is actually something that you guys could, you folks could probably make better as well. We could do some binding and stuff, but right now we just have we have their check status method, and we have our connect method, and you notice that these are all asyncified. Very simple. You saw this connect, I think you saw turn on and turn off, or this power command over in the presentation. But also here we have connect, in which we try to we wait for a connection, so we call the status, and then we have a timeout that's a little longer than the rest of it, so that we can see, hey, is there even anything there? And then of course there's the check status, which calls this the status method, the API endpoint, and then parses the result. And we have we're just using JSON here, so I think this is Newton Soft JSON, which I think pretty much everyone uses at this point. So it's very, very simple. This is a very, very simple application, but you put it all together, and this is really interesting, right? We've built something that is sort of purposely very simple, in the sense that there's not, it's like I said, I'm calling this a dumb smart outlet, power outlet. But there's all kinds of things that you guys could do to expand this and do, just even take what we've done here, not even, hacking another appliance or whatever. I mean, you could do that too. There's all kinds of, sky's the limit. But even just grabbing this code, and you could add I think some easy things that would be fun to add would be like a timer for how long it's on. Maybe you don't want your coffee sit for an hour because it gets gross. Maybe you really like your coffee at a very particular temperature. You could add a sensor and a feedback control loop, so that you could say, hey, is my coffee is it at the right temperature? If not, turn on or turn off. You can control the heater. You can get it dialed in, just a perfect temperature coffee. When your coffee is done, you could send a push notification. You could set a scheduler, so that if you wake up every day at 7:30 or whatever it is, then your coffee is ready. If you have that sort of schedule. So all kinds of things that you could do that, you just grab the code, follow the instructions on the blog to build this out, and then add, all kinds of fun features. I think would be super, super easy to do. And in fact, we have done some work to make working with Netduino a lot easier. And so this is still private. This isn't public yet. We haven't publicly announced this, but I'm giving you guys a sneak peek. I think we're gonna push this out tomorrow. So Netduino Foundation, and Netduino Foundation is at its heart. It is a massive library of peripheral drivers and a beautiful API to access them. And so one of the issues that with hardware development and with Netduino development in particular is that if you go to SparkFun or you go to Adafruit and you buy a cool sensor and you want to integrate it, you have to put your hardware hat on and you have to go write a bunch of low-level code to actually use that sensor. And now with Netduino Foundation, we've made that so that you don't have to put the hardware hat on anymore. You simply add it. You can add a NuGet package for your sensor. I'll show you. This is the website here, and this library is a list of all the peripherals that we support. So you can see it's a huge list, and all of this stuff is published via NuGet. So, for example, if you want to get if you go to SparkFun and you buy an HIH combined temperature and humidity sensor, which works over I²C, you can go to NuGet. You can search for HIH 6130, and up will come the wilderness-labs.netduino.foundation.hih6130 NuGet package. You can add it to your project, and it'll automatically add the Netduino core. And then you wire it up as shown, and then you can get up and running, and here's your API to use it. So all you have to do is create a new HIH 6130, and then you can start reading and getting data from it. So super easy. And I want to say, and there's great API documentation here for all of these. All of the peripherals have API docs, and then there's API docs for the core library as well. So you can see here RGB, PWM, LED. So one of the things that I want to say about this is that we've really spent a lot of time handcrafting a beautiful API to work with peripherals. And so, for example, LEDs are a thing in which are kind of interesting to work with. They're super common to use, but they can be a little bit difficult because if you power an LED from a digital output and you send it 3.3 volts, it will burn out rather quickly. So you have to control and you have to limit the current that an LED or voltage that the LED sees via one of two ways. You can either you can put a resistor in series with it, or you can control it via a PWM signal. And what a PWM signal is PWM stands for pulse width modulation. And that's a fancy way of saying, instead of putting our digital output to high or off, instead of having 0 or 1, what we do is we modulate very fast, 100 times a second or 1,000 times a second or more, on and off. And so if you have, you set a duty cycle of like, say, 50%. And what 50% means is that 50% of the time, as the PWM is cycling on and off, it's on 50% of the time and it's off 50% of the time. And a 50% duty cycle on a 3.3 voltage PWM would be half of 3.3 voltage. So you would actually be sending 1.65 volts. And so you could then run an LED digitally with the appropriate amount of voltage. And that's all well and good, but you have to create a new PWM channel, and you have to, by the way, we have there's six hardware PWM outputs on the Netduino, but you would have to go and create you have to use the API, the .NET Micro Framework API, to go create a new PWM channel. You have to set the duty cycle, etc. And so what we've done is that we've taken a look at all these different components that are commonly used. Which how can we make that much easier? So here is an example of running an LED, and you can do this. You can do this at home if you have a Netduino. You just drop a green LED in a pin 11 and then into ground. Make sure the long leg's in 11. That's the cathode. Add Netduino Foundation, and then this is the code to actually create a PWM controlled green LED. And in this case, so we create a new PWM LED. We specify what digital pin is controlled by. In this case, it's pin 11. And then we also specify as part of the constructor here in PWM LED, and I can show you in the API docs here, if we look at PWM LED, we can see the constructor has a couple of different, it has two parameters. It has this pin, which you saw, and then a forward voltage. So a forward voltage is the voltage drop, or the amount of voltage that it would take to actually power this LED safely. So in this case, we've done something. We've got an LEDs class that has some constants with typical forward voltages. So we have a typical forward voltage class in the LEDs namespace. And in this, we have like green, red, blue, etc. And so you just pass it the typical forward voltage of a green LED, and it'll probably work and not work. I'm sorry, not burn out. And we've done some interesting things here around the API. We've tried to make this pretty sophisticated. And so one of the things that we've done is that we actually support animations. So in this case, we have this pulse animation. And what that does is it'll automatically ramp up the duty cycle over a period of time to that LED. It'll ramp it up to whatever you can actually, when you say start pulse, you can specify the high brightness and the low brightness in terms of percentage. So you could send it to, by default, it goes between 15% and 100%, and so it never drops to completely dark. And so this is a really nice animation that gradually pulses an LED bright. There's also start blink as another animation that we have. And if you're running an RGB LED, and an RGB LED is an LED that has actually 3 LED components in it. It has a red, green, and blue component. And with an RGB LED, by specifying the signal, the voltage level of each one of those individual components, you could display millions of colors. And so the RGB LED has also has set color, but it also has these animations built in. We can pulse on a color. So we've got this we've got a modern color structure here. So you can say start pulse it at orange. You can alternate colors, so you can swap between 2 colors. You can run through an array of colors. In this case, this is the code to show to run an animation of white, yellow, green, tomato, steel, blue, and they're running through these durations, so you can specify the duration. So we've really taken some care to craft an API that makes these things really easy to use. And one of the things that I want to point out here is that this isn't just limited to the output, in this case an LED, but also our sensors. We've done something really, really interesting here. Traditionally, when you work with sensors, updates are manually triggered. So you have a loop and you call read or update, and then you wait for a response, and then so you have you're responsible for managing a thread and whatnot, and it's a lot of code, and it's kind of a lot of management and whatnot. And you can still do that. We still have this update. We still have the update methods on the sensors, but we've done something a little more sophisticated. We've built in a pretty sophisticated eventing API. And so what you can do is that instead of manually pulling, you can create a new sensor. In this case, again, we're using the HIH6130. You optionally, you can change your notification threshold or you can set a notification threshold. So you can say, hey, look, go ahead and notify me when the temperature has changed at least a 0.5 degrees Celsius. and don't notify me until, unless it happens. And that allows you to write very efficient applications that aren't doing a bunch of needless processing. The processing is based on interrupts, and only interrupts when the interrupt has reached a particular threshold. And so here you can see we're subscribing to the temperature change event, and then we're keeping our main thread alive by setting a timeout, an infinite timeout, and sleep. But what this does is this spins up another thread, and in the background, it pulls that temperature sensor. And there's other events on this HIH6130. There's also a humidity change as well, although we're not showing it up here, or we're not showing it here. And so it pulls automatically, and then you can respond to the event. So it's a much, much cleaner way to do it. And we're working also on an additional thing we're hoping to add to Netduino Foundation next week, which is a centralized polling thread manager. And so the idea here is that when you create a new sensor, you would just pass in an instance of our manager, and then all of the polling would happen on a single thread, and we would batch them all up at intelligent times. And so in between that, the Netduino actually goes to sleep, but the CPU would go into low power mode. And so you would have the best of both worlds. You would have a very, very low energy, very power efficient application, but then you would also have this sort of modern eventing framework. And so with this, there's some other things you can do. I'll let you guys go explore this, but you can change your polling frequency here. So one of the things is that, let's say, for example, you're building a connected weather station, and a weather station is maybe it's powered by a solar panel, and so it needs to be ultra power efficient. And so you don't want to necessarily check every 100 milliseconds for what the temperature is. Maybe 10 seconds is enough, maybe 60 seconds, heck, maybe every half hour. So you can specify the update interval here, and then you can be even more power efficient. So let the CPU go into power saving mode and whatnot. So anyhow, that's Netduino Foundation. Like I said, we're going to launch this tomorrow. So keep an eye out for our tweets but you can go and try this out today. You can, if you have a Netduino, you can new up a micro framework application. Just add the Netduino Foundation NuGet. They're all published and up there. It is beta. We're changing it, and we're adding stuff sort of on the daily. We're doing a lot of work right now to add more peripherals and even a lot core components and stuff. But definitely go check it out and give it a run. Have fun and go build stuff. One of the things about this is that really at the beginning of the hardware revolution, I remember, this is really great for me to sort of do this again, because I remember the early days of Xamarin. I would go and I would give talks, and I would tell people, build, the sky's the limit for these mobile apps. They're like, it's a market that's super rich and rich in opportunity, and I had no idea what people would build, but people built such cool things and really changed the way that we interact with our mobile devices. There's so many cool Xamarin apps out there now, so many cool mobile apps, and same thing as with Netduino and with hardware. The opportunities there are abound, and it's only limited by your imagination now, because here's a way to build these things and do them in a much easier way. So there's a couple of questions. I know David has. David, I'll get to your questions here in a second. And then we're gonna open up the Q&A session for more questions. But if you want to grab these slides and have all that, so you can click on all the links. If you go to slideshare.net/Brian Kostanich, you can grab the slides from there. And then the code for, I told you the code for the connected coffee makers up in our Netduino samples repo. And if you grab the slides, then all of these links are clickable, of course. But thanks for thanks for coming to the to this guest lecture, and I hope everyone keeps our lights on and goes and buys a Netduino and then goes and builds something super awesome.
Thank you, Brian. And like you said, I think it's amazing the amount of power that you are, not electrical power, but the power that you're putting into developers' hands with all this is really cool. So congratulations. Like you said, we have a couple questions in here, and if anybody has any other questions, just put them in the GoToWebinar control panel, and Brian's going to answer those. So the first one, was, would the Wilderness Labs Foundation, the Netduino Foundation, be compatible with the old projects that Netduino was based on and using, like Monkey Robotics, which was one that you wrote, right?
Yeah, that's right. So actually, that's a great question. So Netduino Foundation is actually the sort of next iteration of Monkey Robotics. In fact, it started out as a port of Monkey Robotics with all the blocks and scopes stuff, and we pulled the blocks and scopes out. We took a lot of the sort of the best, well, some of the best parts of it, which is the notification and eventing, and we pulled out some of the connectware stuff out of Monkey Robotics, but we actually hope to add that stuff back in at some point. And so if folks are I think a lot of folks here aren't familiar with, when I was at Xamarin, I wrote a library with Craig Dunn and Frank Kruger called Monkey Robotics, and Frank had this fantastic architecture where you could make a block which represents a peripheral, and then you just wire them up in code. You say connect to this peripheral to this other one, and it's really cool. It would enable some future stuff where you could visually, you could write a GUI to wire up code and do robotics and connected hardware that way. So we actually started with that, and then after much discussion and debate, we actually pulled the connecting stuff out and brought in some of the more standard notification stuff. But I think that we're gonna, in a future release, we'll probably pull the connection stuff back in kind of on a different way. But for the V1 release, we wanted something that was super simple. So a good question about Monkey Robotics. The next question you had is, so is the Netduino SDK and .NET MF going to get version updates? So good question. So the .NET Micro Framework was created by Microsoft back in I think 2007. And it was the first part of .NET that was actually open sourced. So it's all open source, and now so Microsoft is no longer supporting the .NET Micro Framework. It's now a community controlled project, and so there are a number of efforts actually out in the community to move the .NET Micro Framework forward. There's some folks building a thing called Nano Framework, which is the rewrite of a lot of the internals of the .NET Micro Framework, and they've done some great updates there, and really moved the art forward. And GHI has done some stuff around Tiny. They have their own version of Tiny CLR, and they've done some cool stuff. And that's really like for them, it's really about like professional products and embedding. And then of course we've done some stuff with the .NET Micro Framework as well, and we are working on, I don't want to say too much, but we are working on a next version of this that I think will be even more powerful and more cool. And I don't want to give away the farm yet, but keep looking, and we're definitely sort of taking charge of this and moving the art forward. So yeah, thanks for that. That's a great question. So Pierre says, as an engineer involved in the manufacturing of the .NET Micro Framework Gadgeteer board, I'm thrilled that a company to investing in .NET Micro Framework. Thanks. My question is, are you going to use the .NET Micro Framework as it is, or are you going to improve the whole framework? And do you know that Microsoft no longer supports it, and what the future is? So yeah, absolutely. We are hard at work building, vNext of this, and it will. I can tell you that it's a very cool, very modern step forward, and something that will blow away everything else out there. Think about what we did for Xamarin, and think kind of along the same lines. So great stuff happening along those lines. So time frame of vNext, I'm not going to commit to anything. We're hoping to have our alpha this summer, but that's plans are, as Ben Gibbard said, plans are a tiny prayers of Father Time. Like anything could happen between now and then. But we're hoping summer we'll have our sort of a limited alpha. But everything that you build on Netduino will move forward. We plan to do an abstraction layer so that you can just run the same code. And so I'd say go out and start prototyping and have fun. Get ahead of the game. Start building and make fun stuff. Sky's the limit. Like it's really about your imagination. That's the only thing holding you back now. And with Netduino Foundation, I think hardware development is just going to be so much easier. Now you got C#, you got modern eventing, and a modern framework with a beautiful API. Animations on LEDs even and stuff. I think that with the Wilderness Labs developer site, lots of great documentation. If you're brand new to this, don't be afraid. Get a Netduino. Go look at our getting started tutorials. Get up and running, and then go do the Netduino Foundation getting started. Order some components and some sensors and start building. I'm telling you, you can do it. If you can build a mobile app with Xamarin, you can build a connected thing with Netduino. Yeah, someone said I'd love to see Netduino overtake Particle. Yeah, me too. I think we'll wait till vNext. Particle's an interesting platform, but it's basically just Arduino. It's still C, C++. And the potential with C# is fantastic. So yeah. Another question: how would one go about building a Netduino proof of concept project to a final prototype for mass production? Is there good resources to look at? Because I ask, considering it's technically a prototyping board. Thank you so much in advance. Yeah, absolutely. So, Netduino really shines as a prototyping platform. But you can take this to production. In fact, there are a lot of we have a bunch of customers that do that have built industrial automation products and stuff powered by Netduino or powered by the .NET Micro Framework. What I would say is start building with Netduino, and then depending on your timeline, our vNext is our vNext product is really focused on moving from the prototype to product stage. So the idea is that we'll have a really embeddable small option so that you can write your application, prototype it with Meadow, which is our next thing, and then go straight to productization. Now, in the meantime, there's still a path. You can build in the .NET Micro Framework using Netduino, and then you can port the .NET Micro Framework to your own circuit, or you can use embedded hardware available from various .NET Micro Framework board purveyors. So absolutely, there is a path. We don't have a ton of documentation up there on that particular path yet, but don't let that stop you. Prototyping and getting your product right is the first step, and we're working on those kind of docs and that guidance. So that is definitely on the roadmap. And thanks everyone for the great responses in here. A lot of folks are saying, "Hey, thanks. This is really awesome to see," and I feel like folks are really inspired to go build stuff. So thank you for having me, and
always a pleasure to have you there, Brian.
Right.
So again, I think the first step for everyone would be to go over to Wilderness Labs or to Amazon, buy yourself a board. It's looking $35 to get started, $40 to get started. Really,
that's right. Anywhere from $35 to $70, depending on the connectivity you want and the power of the board.
really affordable to get started, kind of start poking around at it and playing around with it. Lots to explore. Like I said, you've got great documentation, which is going to help out a lot. So, like Brian said, use your creativity. Go think of cool ideas and send them back out there. And we'd love to see what you're making. So thank you, everyone. And thank you, Brian, again. We always love having you back. So come back anytime. We have a couple more guest lectures coming up in the next month, by the way. So we have one on augmented reality with ARKit and AR Core coming up in a couple weeks. And then in February, one on Azure Active Directory B2C. So sign up for those too. And look for this recording. Hopefully we recorded Brian's lovely face as well with the webcam. We'll try to get that up there. And we'll post that in the next couple days. All right. So
yeah. Thanks, Rob. Thanks for having me. Well, by the way, folks, this is Wilderness Labs. This is where the magic happens. You're gonna first class look into it.
Definitely looks like a lab.
All right, folks.
All right. Thanks a lot.